Here's just one more quick presentation on naming type 2 binary ionic compounds to help you practice before you get to your practice assignment. So as a review, type 2 binary ionic compounds are named with transition metals, for example, iron. Metals in these compounds can form more than one type of positive charge. The charge on the metal ion has to be specified, and to do that we use Roman numerals. Transition metal cations usually require a Roman numeral, but there are a couple exceptions that we went over in the last video. So the rules for naming these. First, the cation is always named first and the anion second, just like our type 1 ionic compounds. But because the cation can assume more than one charge, you specify that charge by using a Roman numeral in parentheses. And to make sure that the net charge is 0, you have to balance out according to how many ions you have of each element. For example, Fe2O3, we have 3 oxygens. Each oxygen is a -2 charge, so that gives us a total of -6. We have 2 irons. Each iron, in this case, to balance out the -6, has to be +3. Since there are 2 of them, 3 plus 3 plus gives us 6 plus, which balances out with a 6 minus. So the name for this compound is iron 3 oxide. Here are a couple more examples. Copper and bromine. Copper is a transition metal. Bromine is a -1 charge, so that means to balance that out, copper must be copper 1 or copper +1. Fes, this is iron and sulfur. Sulfur is a -2 charge. To balance that out, since we have 1 of each ion, iron must be iron 2 sulfide. And PbO2, oxygen is a -2 charge, and since we have 2 of them, that means we have a total of -4. So to balance that with a positive ion, lead must be lead 4 oxide. So again, to name type 2 compounds, name the metal, in this case iron, add the Roman numeral to indicate its charge, and then name the nonmetal with the IDE ending. So if we have FeBr3, that becomes iron 3 bromide. Compare that with FeBr2, that would become iron 2 bromide. There is another system which we're not going to focus on, but I will just mention it here. This is an older system of naming where we use the Latin name of the metal and we either add an ending of OUS or IC, like ferrous or ferric, and then the nonmetal still with the IDE ending. For example, ferrous bromide would be FeBr2, whereas ferric bromide would be FeBr3. Again, you don't need to know the rules for that. It is, they are mentioned on your polyatomic ion sheet. If you want to download that, that would be helpful in naming these type 2 compounds. So let's do a couple practice problems, and then you should be ready for your practice assignment in the next, as your next assignment. So the name of the compound, CrO2. All right, we have to look at oxygen. Oxygen has a -2 charge. If oxygen's -2 charge, it has to be balanced out. That means that gives us a total of -4. So chromium here has to have a chromium 4 oxide name. Just glance at this periodic table for a moment as we move into the next problem because it's a little trickier. So what's the correct name of the compound that results from the most stable ion for sulfur and the metal ion that contains 24 electrons? Let's go back to the periodic table and look at sulfur. Sulfur is in group 6. That means it has a -2 oxidation number. So whatever transition metal we pair that with has to work out to a +2 charge. So our options are iron, chromium, or nickel. So let's go back and look at something with 24 electrons. If we look here in the transition metal area, if the element was neutral, not an ion, it would be chromium. But these compounds are ionic compounds, which means we're working with ions. So they have an unequal number between protons and electrons. So let's go back. We've got to find something that balances out with -2 for sulfur. If sulfur is the -2, that means our metal element has to be a +2. So which element would have 2 extra protons? If we go back, here's 24, 2 extra protons would be iron. So the name of this particular compound is iron 2 sulfide. So that was a little trickier there, and don't expect to see any tricky assignment problems like that, but just so you are aware, this is how it would work out. So here's a helpful chart for you. This gives ions for transition metals that we would use commonly and their systematic name. The older system would name them this way. You don't need to worry about that, but these are all possible transition metals you might use in compounds: iron, copper, cobalt, tin, lead, or mercury. As always, if you have any questions, don't hesitate to ask.